A level, remember A level, you know, you have 1, right, 2, up to, you know, A level, you know, multiple level. And factor B, you have, you know, 1, right, 2, and also up to the B level. Remember the previous example about the primer, you have the 3 level, right? Primer type 1, primer type 2, and primer type 3. And the application method, you have 2 methods, right? Dipping and spraying, or others, you know. So you have 2 factor. Today onwards, from today onwards, our focus should be on 2 power of K design. Okay, from now onwards, now mean today, you know, 11 November until our semester ended. I think our semester ended is end of January 2022. We will focus on 2 level only. We are focused on 2 here. 2 mean here 2 level. That means for previous example, we have multiple level, right? A and B level. But from today onward, we special focus on here. 2 level only. That mean 2 level mean low, okay, low and high. From now onwards, we focus on 2 level, okay, 2 level low and high. Usually low we put as negative, you know, and then high we put as a plus. We put as a plus. However, the number of factor is increased. Although level is maintained 2 level, but factor K, you know, K, where is K? K refer to number of factors. Number of factors, you know, more factors. That means we are not focusing only factor A and B. We are focusing more on factor, you know, number of factors, you know, A, B, C, D, E, you know, up to how many factors. For example, for machining operation, right? Machining, we talk about cutting speed, fit rate, depth of cut, cooling type of materials, so many, you know. So this is typical example of FYP project. FYP project, or project in a company, or project during your intern, we talk about multiple factors. So that means from now onwards, level we fix at 2 only, low and high, or in symbol is negative and positive, and we focus on number of factors. Okay, number of factors. Okay, this factorial designs, the theory, right, is widely being used in your FYP. So I expect for FYP project, you know, for your FYP project, you should expect using multiple factors, you know. I don't know, maybe some student only 2 factors, but if you use 2 factors, you have multiple level, you know. You have multiple A, you know, so many level A and so level B. You cannot use A and B and then 2 level. Too simple. A textbook problem, you know. It's a textbook problem. Okay, so that means it has been used in many real case, real industry, intern, FYP, research, you know. And in order to identify the factors, right, you must read literature review. That's why LR. That's why for your FYP, you need to carry literature review. For example, on injection molding, in machining, soldering, any processes. Okay, you must review related literature from previous work. You know, that's why. And then to identify what? To identify the factors. Oh, sorry guys. To identify the factors affecting response. You know, response. For example, yesterday example on respond on the force, on the strength, on defects, on reject. So basically, all this you need to identify. This is the background of the problems. You know, for FYP1, you know, final you need to identify the scope of the study, what are the factors, how you plan to carry out your experiments, you know, doesn't matter. And then you literature review is you need to review of the previous work on your particular areas. Okay, so this level, right, low and high, It could be quantitative. For example, if you talk about temperature, you know, maybe you run at 60 to 70 degree, you know, something that we can measure, you know, pressure or time. This is quantitative, you know, numbers, right? Temperature 60 to 70, you know. Sometimes could be qualitative. Remember the previous example, you have Premier type 1, Premier type 2, Premier type 3, you know, the type or machine or operators or sometimes a process, you know, dipping process. So sometimes this level could be quantitative or measured value, or sometimes based on qualitative, you know, just categorical, you know, categorical. So you can do that, categorical, you know, category. Machine 1 from Japan, the machine 2, you know, category. You can do this, okay? And for today, I think we focus on a simple, today, 2 by 2 design. That means 2 level, 2 factors. For today, this is a special case lah. Special case, no? Special case, 2 by 2. That means 2 level, 2 factor. 2 level, 2 factor. So today. So basically, it's the background of today lecture and continuation from yesterday. You know, yesterday we got 2 factor, multiple level. Multiple mean 1, 2 up to A, B. But today is a special case. You know, 2 factor, but 1 and 2. B also 1 and 2. So I hope you can clear. You have understand the difference between yesterday and today lecture. Okay, if you are interested, right? If you don't like my lecture, so you can watch your YouTube, you know, your YouTube video, right? You can type YouTube video, you can type 2K factor design, somebody will give you like 10 to 15 minutes to get the idea what is factor design, the purpose, that kind of thing, to get the understanding, you know. So that means in this today environment, knowledge you can get it from all over the place, all over the world, other universities, you know, UK, US, mostly on US universities, US. So you can watch YouTube, and then you just type this in the Google search, then you will watch at your own sweet time, you know, own sweet time. Then you can get the understanding, further understanding what I have, you know, giving you today, giving you today. So basically, in this environment, in digital environment, social media group, you can find a lot of sources, you know, on the internet, whether you you want it or you don't want it. Okay, that's the requirements, right? Okay, this is the procedure. The procedure means the methodology, right? This is the methodology. Okay, this is the methodology. The methods, the methodology, which is in your FYP chapter 3. Methodology for conducting factorial design. You have methodology, you have to follow certain steps, methods, right? In FYP, they call it chapter 3. How you want to carry out your FYP. Chapter 3. For our class, factorial design, also they have methodology. First, you identify the statement, the issue, you know. Then you identify the factor effects. Factor mean main effects, you know, main effects. Remember, main effects, and also the interaction effects. Main effects, and also interaction. I think the case is very interaction effect. Interaction effect. If you talk about two factor, right? Only main effect of A, main effect of B, and interaction effect of A and B. Interaction. Okay. Formulate the model. We will do, okay. For laboratory, from now onwards, you need to replicate, you know, in your experiment. It's not enough you run just one single replicate. You must use replicate. Data analysis using ANOVA Okay, using ANOVA, and must use the software. You must use the software, right? Software, I mentioned many times, right? The software for our class is called Minitab. Minitab. I think by now you should install, right? You should install in your own laptop. Install, right? You should install at your own laptop, so that all analysis laptop, right? Laptop, that means for FYP project, for FYP project, you must use software. Okay, this is statistical analysis. Also, that means both. You need to analyze statistical analysis on graphical analysis, and always no point, collect the data, estimate the model, do some elegant analysis, but you must be able to interpret results for decision making process, for decision, DECI, for decision making process. What does, how can we, decision making? This is the most important thing, decision making process. Decision making process. That's the most important thing. Any issues, collect the data, prepare data collection sheet, analyze, and then making decision, right? For example, now we talk about claim loss all over the world about ivermectin, all pills, all this. We need to collect the data. Or now vaccines, right? Malaysian would like to generate their own vaccine, so we need to test the effectiveness, the efficacy of Malaysian vaccine, for adult, for youngsters like you, for children below 5. All these need to collect the data, based on the data. You cannot take the data from overseas. That's why I think before we take our own vaccine, we have to test in our own lab, right? Our lab. Then Malaysian will give it to public for vaccination process, right? So basically, the way to make decision based on data, collect data. You don't make decision based on fake news from internet, social media, or corrupted news or corrupted papers from an unvaccinated guy from the US. Okay. Okay. This is the methodology, right? The methodology. Okay. As this is special case. Okay. This is special case, right? Special case 2x2 design, right? That means what is 2 here? Oh, sorry, guys. 2 here mean 2 level. 2 level. Right? 2 level. 2 here, 2 factor. 2 factor. 2 factor. Okay, 2 factors. In fact, we are targeting for 2 power of k design, right? K. K number of factors. Number of factors. That means could be factor A, B, C, D, E, F. Uh, uh, for today, 2, that means factor A, factor B here. Here, for today, right? This is factor A. This is called factor A. Oh, sorry. Factor A. Okay. Factor A. Here, factor B. Here, factor B. No? Factor B. Okay. If 2 factor A, factor B is a plane. 2 by 2 is a plane. Plane is like a mirror, like this. Only X and Y exist. Okay. You can see here, 2 by, okay. 2 by 2. Oh, sorry. Okay. 2 by 2, factor A. Okay. 2 by 2 is equal to 4 runs. 4 runs. Oh, 4 runs. 4 runs. Okay. This run, right? Run. This is run. Okay. This is run 1, right? Run 2, run 3, 3, yeah, run 3. I don't know how. And this run 4, 3, very 3. Okay. There are 4 runs. That means how to interpret this? 4 runs, look at this corner, corner. Factor A run at low level, B run at low level, the symbol is 1. When symbol 1, that means factor B run at low level. Okay. Factor A here, right? Factor A run at high level, B low level. You put symbol A, symbol A here. Okay. And here, factor A low level. Here, factor A. Yeah, correct. Factor A low level, B high level. A high, okay. This one A low, B high, okay, and finally A and B high here. A and B high. So basically, this is the arrangement. Okay, this called standard order design. Standard order design. Standard order. That means if you talk about 2 by 2, that means this is the standard order design. That means one mean factor A and B at low level. If you put A, that means A at high level. A here, A at high level, B at low level. Okay, B A low level, B high level, and A and B point here. So I hope you understand about how the arrangement on the matrix for matrix for the matrix. Okay, this is for factor A and factor B, 2 level. The is the plane. It is called a plane. It's a mirror. Plane. Okay, this is called a plane. Okay, plane, right? Okay, these are examples. I think this is an example, the theoretical example, right? I don't know why they put example here. Okay, example, maybe they say the objective, right? For FYP, you need to, sorry guys, please make it bigger. For FYP project, you need to identify the objective of your study. The same thing apply to object of experiment. That means what are the factor? Factor A, 2 level, low and high. Low is negative, this is plus. Okay. Factor B, right? Okay, high plus 2 pounds. Okay. Low, negative, okay, at 1 pounds. Okay. This is a factor. Okay. And then replicate 3 times. And total number of runs is 12 runs. And experiment must be complete in random in order to avoid bias. Everything must be done in random. That means equal chance. Random, right? Random. Okay. So basically, when you read the story, right, you must be able to understand. I mean, the researcher, the student, the final year student is investigation. Because for FYP, right, for FYP project, your job is to investigate something, right? You want is to investigate something. Whether you want to investigate the food pain, whether you want to investigate the reaction, the effect, the strength, simulation, whatever. You must investigate something. I hope by now, students, this when you try to develop topic for your final year project, right? Part 1, you must think in your own mind. You must investigate something. What you want to investigate, you know? You want to investigate the effectiveness of CanSino, Moderna, Pfizer, Sinovac, Sinopharm on what? On children below 12 years old that they can investigate. You want to investigate the strength of certain materials. You want to investigate what? I hope by now your thing, you must be able to investigate. This is your engineer. Engineer is to investigate something. Okay? Investigate what? Factors affecting the response. You know, for our class, factor, effects of, okay, this factor, right? Concentration and the amount of the catalyst on the yield. So you must think your own for FYP project. Why you want to investigate something? Investigate, you know, like special investigator, right? Special investigator. Your job is special investigator. Okay. I hope clear, guys, to find the topic for FYP. Investigate something. You must investigate something. If you don't know, ask your supervisor. Okay, I think. Okay, I think this example is the data. This example, okay. The place, okay, this is the data. Always make it bigger. Forget early in the morning. This call data, you know, collection sheet, right? Data collection sheet for 2x2 design. You know, 2 level, right? Low and high. 2 level, low and high. Okay, and then you have 4 runs, 2 factor A and B. This run, I put here, run. Run. 1, 2, 3, 4. Symbol, you know, symbol. Symbol. 1 and 1, that means 1. Put 1. 1. This is A, you know, A. Okay. This is B. This is AB. That means A high, B high. Okay, I hope by now, guys, you must be able to understand or read this data collection metric. You have 4 runs. If you have 3 factors, 8 run. 4 factors, 60 run, and the rest. Okay, this is the interpretation, right? But in terms of symbol, if factor A low level, B low level, you put 1, and then is A plus, that means A high level, this one B, and then A and B, and this is your raw data. This is your raw data recovery or yield, and this is the sum. Sum means the sum of each rows. I think for FYP1, you just plan your data collection metric. But for FYP2, you start collecting the data here. Okay, and then start doing the analysis. Okay, this is your data collection matrix from the previous example, right? From the previous example, A to level B and Y is the yield recovery or yield. Let me put so that you understand the concept, the theory, yield recovery. This is data. Data, you cannot cheat the data, you cannot cook the data, you cannot massage the data. Data must have integrity, honesty, whatever, right? Okay. Data collection matrix. Data collection matrix. Okay, this is the graphical formats, right? From the previous example, you know. Remember, factor A, low level, high level, factor B, like low level, and then they put the data in in terms of graphical. So I hope you can visualize. I think for FYP, right? For FYP student, you must have photographic memory, you know. Photographic memory as engineer, you must have photographic memory. Photographic memory so that you know from previous data collection metric, you be able to visualize the data. Visualize, you must be able to visualize the data into a geometry, okay, in terms of geometry. I think this is very important. As engineer or a FYP student, after intern, whatever you see, you must be able to uh, to see them in terms of graphical or in geometry. This is the data, right? I think this is the the interpretation, right, of this graphical data from your data collection matrix. Data collection matrix. This is a plane, right? This is a plane. Okay. Okay. Plane. Okay. To calculate the main effects, right? Okay. Hold minute. Hold minute. Okay. Here, right? Main effects of remember. Okay. Hold minute. Hold minute. Main effects. First, make it bigger. Pencil, right? Main effects. Main effects of A. Because here, main effects of A, A is equal to, you look at this A, factor A, okay, this A is A, okay, this is B. If you want to calculate the effects of A, look at A at high level. A at high level is here. This is A at high level, right? A at high level. That means A, right? A plus, this is A, right? A plus AB, AB divided by 2. Okay. Minus A at low level here. This is A, right? This is A at high level. This is A at low level. That means 1 plus this one, B. 1 plus B divided by 2. Okay. Similarly, for main effect of B. Similarly, main effects of B. Main effects of B. I think main effects of B here, right? B, this is B low. Here, see, B low. B low. This is B high. So main of B is B at high level. That means B here, B at high level, right? B here. See there, B at high level. Here, right? B plus B plus AB. AB plus AB, right? Divided by 2. Average 2. So minus B at low level. This one B. B at low level. Here, right? 1 plus 1 plus A, right? 1 plus A, and then divided by 2. Okay, this many effects. And then another is called interaction effect of AB. Interaction effect, I put here, AB in of AB interaction effects. Look at the diagonal here. Diagonal. Okay, intersection effect diagonal, diagonal. Diagonal, that means diagonal mean what? AB, 1, 1, 1 here, right? 1 plus AB, 1 plus AB, divided by 2, average of the two, minus this diagonal. This diagonal. Diagonal. That means 1 plus AB minus this diagonal, that means B plus A, B plus A, this diagonal, remember this diagonal, B plus A divided by 2. Okay, that means from this geometry, you must be able to derive main effects of A, that means here, A at high level, minus A at low level, right? And then B at high level, minus B at low level, and interaction of AB. Okay, this is your derivation, right? Derivation. Okay. I hope you can follow this very important fundamental the theory, and then this 2 by 2, guys, 2 by 2. We can develop similar analogy for 2 by 3, 2 by 3, 2 by 4, and the rest, but concept are the same. Okay, main effect of A, main effect of B, and interaction effect of AB, that means the diagonal. Right? Diagonal. Okay. Oh, yeah, I think this is the one that I mentioned. You can see there. Okay, 1 over 2, n number of replicates, doesn't matter. N here, number of replicates. That means if assuming n equal to 1, that means 1 over 2, right? N here. N refer to number of replicates. Number of replicates. Number of, that means how many points? I think for previous example, there are 3 replicates, right? Number of replicates. So this is how you derive main effect of A, main effect of B, interaction effect of AB that I just, show you, right? The diagonal. AB plus 1 divided by 2 minus A plus B divided by 2. And then you simplify mathematically, you will get this. N number of replicates, N number of replicates. In our if assuming 1, that means 1 over 2. If in our example 3, 1 over 2 by 3. Okay, this is how they derive from the plane. This is how they derive it. Okay, derivation. Okay. Okay, this example, I think you can do this to calculate mini effects. I think this one to calculate many effects of A. Forget all this. No? Main effect of A, main effect of B, right? Main effect of B, and then interaction effect of AB. Just application of the formula. This is the application, right? Application of formula, how to calculate main effects of A, main effects of B, and interaction effect of AB, right? Interaction of AB. Okay, application only, nothing fancy. Okay, this is very interesting, right? As I mentioned, very interesting. Okay, whatever value, remember value inside. Oh, okay. Whatever value inside here is called contrast. This is called contrast. Contrast of A. For example, contrast of A. How you get contrast of A? Like this. Okay, let me demonstrate. Contrast of A. Contrast. Contrast of A equal. Look at column A. Column A, right? A minus 1 minus 1, right here minus 1, plus A, and then minus B, and then plus AB, then plus AB. So you rearrange, you get AB minus B minus 1. Okay, contrast of A. Look at this. Look at this metric. No, look at this. Then on the standard order design. Okay. Contrast of B, similarly. And then you can understand why you need a contrast later on. Contrast of B. Just follow and look at the column B. Contrast B. Look at column B. Okay. Look at column B. Column B. Minus 1. Minus 1. Minus A. Right. Minus A. Minus A. And then minus B, plus B, plus B. Plus B, and then plus AB. Plus AB. Okay, to get interaction effect of AB, this is from standard order design, guys. From standard order design, this standard order design, right? Negative plus, you always start from negative plus, B, negative plus, okay. For AB, you just multiply, you know. Column negative, you got plus, negative, you got negative, okay, plus. So, contrast of AB, contrast, contrast of AB, just follow, look at the column. Contrast AB, plus 1, plus 1, minus A, and then minus A, minus B, and finally plus AB, okay? This is how you get contrast of A, contrast of B, contrast of AB based on this standard order. As I mentioned, this method is called standard order design. I always plus, identity metric always plus. Okay? I is always plus. This called for 2 by 2 design, 2 by 2 design. Okay, why you need to know contrast? Okay, why you need to know contrast? This one. Why you need to know contrast? Because, okay, let me hold. Why you need to know contrast? Here. You need to know contrast. I think here. Oh, sorry. Oh, pencil. Okay, correct. You can calculate any effects using this formula. Effects, you know, with the main effect of A. For example, if you want to calculate effect of A, that's why you need to know contrast. For example, you want to know effect of AB, effect of AB. Effect of AB equal contrast AB. Contrast AB that I just derived you. Contrast AB. Contrast AB. Okay, divided by N number of replicates, right? N number of replicates 2k minus 1. If k equal to 2, for example, 2 factor, right? 2, that means k minus 1. K number of factors, sorry. K minus 1. That's why you know contrast, so that you can calculate effects of A, effect of B, effect of AB by using this formula. Another is to calculate sum of square. Remember, in order to analyze 2 by 2 design, you must use ANOVA, right? So you must be able to calculate sum of square. So again, for example, you want to calculate sum of square of AB, right? If AB is equal to contrast of AB square, you need contrast. Contrast, right? Contrast AB, contrast OAB, you need to square that. That value of the contrast, square that, and then divided by n, number of replicates, and 2, and depend on k. If k is 2, is 2. K 3 in the case. That's why you need to know contrast. So from now, calculate sum of square A, sum of square B, AB, then you can cut. Okay. I think this is a different formula, right? If you use two-factor multiple level, you calculate a very long formula. But if you are using only two-factor, you can use this formula. So you can use this formula, effect and sum of square, contrast. Okay, that's why we need to know contrast. Oh, here. Okay, contrast can be used to calculate effects, sum of square. That's why you need to know contrast. We need to know. I think you might as well you write this in your cheat sheet for test 1. For test 1 to calculate the sum of square or contrast. Okay. I think I will get back to the original slides. Okay. The original. Okay, the original slide, right? Oh, I think it's advanced. No. Get back to our original because I want to introduce contrast. Here. That's how you do it. Contrast. Why? The contrast is used to calculate effects and sum of square. That's why you must be able to derive the contrast from this matrix. From this matrix. Okay, this is the application, right? The application of the contrast. Sum of square, contrast square. Remember? N2K for two. I think this is for special case, right? This is for special case 2 by 2. This is for 2 by 2 case. Two by two. Sum of square A, contrast square by N2K. N remember N2K? N2K. 2 power 2, 4, right? Sum square, contrast square, B, contrast square multiplied by N2K. And then you need to calculate sum square total. This is the only way that you must calculate manually. Sum manual. That means you must use your scientific calculator to calculate SST for individual observations, the sum, and by I think 12. I think 12 is it the replication, right? Okay. This is ANOVA, right? The ANOVA of the figure 6.1. This is ANOVA, right? ANOVA. Okay, ANOVA, sum of square. I think this ANOVA refer to this whole minute. This ANOVA, yeah, refer to this. Refer to this example. The ANOVA. Refer to this data. Please take note. Refer to page slide 18. Okay, let me slide 18. Okay. Refer data slide 18. Slide page 18. right? 18. That means you have factor A using sum square using the contrast, sum square B using the contrast, and then this one SST. Remember long method, SST. Okay. After you know this, so degree of freedom should be with these two level, one mean square, okay, and then you compare your F, right? Assuming F, right? F 0.05, F05. You usually in interactions, interactions, right? Interaction. Look at this. F05 18 degree of freedom. 18. Okay, look at the table. F table, right? And then you compare this value, 2.13. Is it bigger or smaller than F table? Okay. If it is bigger, then you reject null hypothesis. If it is smaller than F table, do not reject null hypothesis. That means the interaction is not significant. Okay, not significant. Let's check the results. Okay, there's no results. Okay, there's no results. There's no result for this example. But I think for this, okay, I want to remind to students here. Remind, you should practice, right? I think you should practice on your own. Practice your own develop, construct this ANOVA table, whether you get the values or not. Okay, first manually, I mean long method, manually. Another this first. Okay, guys, first. Second, construct, CONS, CONS, construct, construct ANOVA table using Minitab. I think, guys, using ANOVA table, ANOVA table, above table, ANOVA table using Minitab. So why Minitab? Using Minitab. So basically, Minitab. I mean, practice on your own using a formula. Another is using Minitab. Okay, if you can get this table, that means you understand the today topic. So please practice. Refer, right? Refer raw data, page 18. Page 18. Okay, you have raw data page 18. You construct ANOVA, right? Using manual calculation, and then similar data you key in Minitab, you will get similar results. If you can get the result, that means you are understand the today lecture, right? Today lecture, okay, today lecture, yeah, and interpretations. Okay, look at this, right? Interpretations. Okay, that the first exercise, to enhance, to strengthen today's topic, right? Today's topic. Okay, this is the first exercise, right? This second exercise, okay, this is a second exercise. Second exercise, Do your own, guys. Second exercise. Similar questions. You can do this manually using two approach. Solve this. Solve as assignment. No need to submit. Solve your own. First, manual calculation. Manual. Number two, using Minitab. Using Minitab. Okay. So what are the problems? What are the problems? This is the problem. It is important to study or to investigate, right? In your FYP. FYP is to investigate, to study, to find, to whatever, right? To investigate. The final year student is interested to investigate the effect of concentration of a reactant. Yeah, factor A here, right? And the feed rate here. Feed rate on viscosity, that means the response. So I hope after you read this, however, for your FYP, you need to formulate your own problems. Formulate your own problems through literature review, through asking your supervisor, through reading internet, through reading YouTube, through asking your friends. Okay. For example, you read, and then you come to see your supervisor. You say that from your reading, you want to investigate something, or if your supervisor get project, become very easy. Right? They just, okay, you study this because based on the project. But if your supervisor have project, so you need to think your own topics. Okay, own topics. So by now, after you read this, you must be able to identify, factor A, factor B. Okay, let reactor go. Okay, factor A 15%. Factor A here, right? 15% low level, 15 high level, 25 fixed. You remember fixed? You set the setting. Okay, and then feed rate factor B, 20, 20 and 30, 30. The experiment involved, okay, 2 experiment runs. That means replicates 2 times. Replicate 2 times. If for combination low, okay, viscosity reading, that means the response. Okay. By now, I think students, by today's lecture, you must be able to visualize this. Okay, I hope you must be able to graphically have memory, run, remember run? 1, right? 2, okay? 3, for whatever reason, 3 and 4. You have factor A, okay? You have factor B, okay? Remember, start negative, right? Negative plus negative plus, then negative, negative plus plus. Standard order design. The symbol, this is the symbol, this is 1, this is A, this is B, this is A, B, okay, and then the data, put the data, first replicate, second replicate, first replicate for A low here, 1, 4, 5, put here, 1, 4, 5, and then 1, 4, 1, 4, 7, and the rest. So from this graphical diagram, you must be able to put in the data collection matrices. Okay, this is how to understand the problem, to understand the issues. Then this is typical question that will be asked for test 1 or the final. This is typical questions. Typical questions, right? Calculate the effects. Effects, that means calculate the main effects of A, right? Using the main effects. Main effects. Main effects of A, main effects of B, and two interaction effect of AB. Using the formula of effects. Contrast sebagai R2K minus 1. K effects. Plot, that means you must be able to plot the AB interaction plot. AB interaction plot. AB interaction plot. Remember yesterday, I show you how to construct the interaction plot of AB, right? For primer and application method. Plot, interaction plot. Interaction plot. Okay. This one construct ANOVA. Construct ANOVA. Construct ANOVA. Construct C, construct. Sorry, always run. Construct ANOVA. Construct ANOVA table. Construct ANOVA table. And this one interpretation. D is interpretation of test by effect final conclusion. You see there? Final. That means you need to make some interpretation. This is interpretation. Interpret from ANOVA. Interpret the results. Interpret results. Results of ANOVA. Okay. One question, typical, typical test 1 question. So you need to practice. You can do practice. Remember, you can do this manually, and then if you want to verify your answer, you can key in this data inside the Minitab. If you get similar results, that means your result is confirmed and correct, right? So you practice this, right, for your test 1, right? For test 1, that means this typical example. So I think the test 1 will be like this. Will be like this, or will be like previous example, So you practice, guys, practice on this typical question, typical problem, analyze using manual calculation, and analyze using Minitab. Minitab. Okay. Okay, this is, I think the first question, this is second questions, right? Second questions. Okay. Okay, this is another questions for practice. This is another questions. This is another, let me put, oh, sorry. This is another question that you can practice. Another question, Q, right? Q, again. Practice using manual. Always remember, guys, you can use using manual. Number 2, you can use Minitab. Minitab, right? Minitab. Okay. This is run. This is run 1, run 2, run 3, run 4. This is standard order design. Okay, given here, and then you have 4 replicates. Is it? Yeah. 1, 2, 3, no? 4 replicates. Total average. Okay. If you look at this in the plane, if you look at the plane, okay, like A here, this is B, right? Sorry, B. And then you have 4 replicates here, 4 points here, 4 replicates. For example, here, this corner, right? This corner, which is this corner, which is this corner. Okay, this is only to understand the problem, the issues. Okay. The response variable is expectation layer thickness micrometer, wingspan estimate using equation. I think the application of finance, basically, I don't know whether this have some solution or not. I don't know whether there is some solution or not this problem. Okay. They are given you the calculate the sum score A, B total. Okay. Let me check. Okay, no. I think you need to consult the ANOVA, right? You need to consult ANOVA given this. So again, you must practice. I think this solution. This is only some part of solution. This is only some part of solution. It's not incomplete. Because as I mentioned, the first maybe construct ANOVA table. The solution, construct. Need to construct ANOVA table. Remember, typical question, you will ask. Construct A. Construct ANOVA table. When I say ANOVA table, it's like this, guys. ANOVA table, you have SOV, remember, SOV, A, B, AB, you know, you have error, okay, like that, this is called ANOVA table. Number 2, plot effects, main effect plot, okay, plot main effects, always very difficult, right? Very difficult. Main effects. Main effects. Main effects of what? Main effects of A, right? A, B, and also integer effect, A, B. A, B. Okay, 1, 2, right? And then number 3, maybe interpret the ANOVA. Interpret. Okay, interpret. So basically, in this particular solution, they only give calculate SSA, SSB, not in. You must complete typical like the previous exam. So basically, today lecture, I give you 3 questions that you can practice. Okay, you can practice on your own. Practice, especially this. So, you have 16, practice of squaring this. It's no joke, This one. Practice calculation this. Practice using scientific calculator for the test. practice. Calculation of S, S, T. Make sure you got this value. 3.0672. If you don't get it, you must practice over and over until you get this. To me, you don't try to practice during the test. Don't do that. Because if you practice this calculation during the test, it's a suicidal. Suicidal. No, you don't try to make an attempt to calculate some square, calculation for 16 data, 16 is no joke. 16, you have to square and then and using the function. Don't use the manual, square that. No. You must use the function of your calculator. You must use the function. Practice that. If you don't know the use the function, you can use YouTube of using maybe Casio or Texas Instrument 5000 series. So they will give you, okay, first push this button, that kind of thing. No, usually before the COVID-19, I will ask you all, practice calculation this. Since it's a virtual online, right? I cannot do that. Right? So basically it depends on you, I just only give you the guidance only, right? Guidance that you must do this, but you must do, must do. If in a physical class I can monitor you, calculate all this, but now I cannot monitor you, right? Whether you are still listening or you are still sleeping or you do somewhere else, or you do somewhere else. So very difficult for me to monitor your activities behind this black box, right? The black box. Okay. I think I've given you 3 questions, three practice problems, practice questions. Okay. Okay. For residual analysis, you can do this using the 2 by 2. Remember EIG, right? Residual analysis. EIG, right? Actual observation, YIJ minus, I think, Y bar IJ. Okay, residual analysis. Okay, residual analysis. But Minitab, you can just redo button. I think click residual, they give you the data like this. Okay, what does it mean? Residuals, the error, the most important is the error. The error in your experiment must be normally determined mean and sigma. The mean error. The error must be normally distributed in your experiment. In a straight line, straight line. I think you can use this the error for deposition time. I think you can refer this on the textbook on how to calculate the residual for deposition time for the previous example, and also the flow rate, right? And this is the okay. What time now, Okay, we can continue. Okay, remember. Okay, guys, any questions, guys, regarding for 2 by 2 before I move to the 2 by 3? Any questions? Any questions? I think any question, guys? Any questions regarding our topic today? 2 by 2. Okay. If there is no question, I'll continue on. Remember, our previous lecture is 2 by 2. Right now, I move to 2 by 3. Okay, 2 by 3. 2 by 3, right? 2 level. Okay. Let me recapture back, right? Okay, recapture back. Oops, sorry. Okay, 2 by 2 is a plane. Is a plane, mirror. Plane. This is called a plane. Plane. Like you see in your computer now, it's a plane. Like it's a plane. 2 by 3. 2 by 3 is a cube. Is a cube. Here, the example of 2 by 3 designs. 2 by 3 design is a cube. We have factor A here, factor A, factor B here, and factor C. And if you got power 4, that means human being cannot visualize this. Human being cannot visualize. Human being cannot visualize 2 by 4. However, mathematically we can do human visualize because human only can see 3 dimensions. No, human can see a point, 1 dot. Human can see a plane. Human can see a 3 cube. Look at your own room. It's a cube. But 2 by 4, human cannot see. Human cannot see, right? Maybe 2 by 4 is like if you know, like smoke. Smoke n dimensions, like smoke. Maybe like that, n dimension or n hyperplane. I know hyperplane. However, mathematically we can visualize. Mathematically, mathematically. The only we cannot see through our own eyes. Okay. 2 by 3, similar concept. Put here, if 2 by 2 plane, 4 runs. Oh, sorry. Here, 4 runs. 1, 2, 3, 4. If 2 by 3 is run, 8 runs. Here 8 runs, 1, 2, 3, 4, 5, 6, 7, 8 run. 2 by 4, 16 run. 2 by 5, 32 run. So as you can see here, as the number of factor K increases at 2 levels, the number of experiment will be increased exponentially, like this. No? This factor, right? Factor. Yeah. This factor. For example, you have one factor, single experiment, right? One factor, single factor, remember? Single factor experiment. Then we have 2. And then when I say exponential like this, as the number of experiment K increases, it's a number of factor K increases, the number of experiment will be increased exponentially. That means very costly. Very costly. For example, can you imagine if you run experiment very expensive? For example, we want to conduct experiment for a new vaccine for Malaysia. So, very costly. First, maybe you want to test on human being. Human being. That's some effects, right? For example, like AstraZeneca, right? AstraZeneca. They say it will cause a blood clotting, right? In the UK, in Malaysia, blood clotting. So this is a side effect of experiment. Okay. So this is 8 runs. Remember here, 0.1, that means 1. 1 means A at low level, right? A at low level. This low, remember here, guys. This low. Low. This is high. B low. This is high. B low. L. This is high. If you look at this point, this little corner, A at low level, B at low level, and this is the one here. The symbol here, symbol S. Here should be 1. 1. Here should be A. Here should be B. Here should be AB. Okay. Here should be C. Here should be AC, right? A, C. Here should be BC. And finally, you have ABC. ABC. That means what? Here. What does it mean? Factor A at high level, B at high level, and C at high level. Okay, I hope by now this called standard 2 by 3. They call it standard order. Standard order design. Standard order design. Okay, this concept, whether 2 by 2, 2 by 3, 2 by 4, is similar. Is similar, although you cannot see it's 2 by 4, right? A, B, C, D, you cannot visualize in terms of geometry because we as human being cannot see up to 4 dimensions. I don't know, maybe if you know, Genie can see 4 dimensions. I don't know. Genie, if you're Genie, maybe can see 4 dimensions. But for us as human being, we only see a cube. But mathematically, we can derive. Mathematically, for example, mathematically, we talk about a 4. Then you just add here, right? A, B, C, D, 4. Okay, 4, E, 5. Similar thing, you know. Just continue. If you got D here, you have 8 negative. 8, you know, if you got 4, got 4 should be 16 runs. 16 runs. 16 runs. Right? 4 is 532. 532. That's why as the number of cave increases, so the experiment will become humongous, and cost you a lot of money, time, energy, whatever, right? That these are all 3 factors. Okay. Okay, then you can do this. You can do this. Remember, you can because this is main effect, right? Main effect A, B, C. Remember, you want to construct the ANOVA. You need to calculate effect and contrast. You need to know this. What column here? No, A, B, right? A, C, A, B, A, C, A, B, A, C, B, C, and finally A, B, C. Finally, A, B, C. So you can, for example, AB, you just multiply. AB plus negative, AB interaction. Just look at column A, multiply column B. Negative plus, negative, negative, plus, plus, negative, negative, and plus. Okay, okay, guys, make sure, you have 4 plus, 4 negative. You know, they call it orthogonal. 1, 2, 3, 4. Okay. If you want to know ABC here, maybe the last column ABC, you just multiply column A, multiply by column B, column C. ABC should be negative, right? Negative. This one should be positive. This one should be positive. This one should be negative. This one should be positive. This one should be negative, negative, and positive. So this is the this is the configuration for A, B, C interactions. Three-way interaction. We call it three-way interaction of A, B, C. That is, this is the configuration. You know, multiply column A, column B, column C. You got this one. 1, 4, 4 negative, 4 positive. 4. Okay. So I hope guys, you must be able to visualize in terms of graphical and in terms of design matrices, so that after you know this, you must be able to calculate what? To calculate the effects. Remember the formula effects? Contrast, right? Effects. Then the effects. And calculate sum of square using this kind of configuration. Configuration. This is very interesting, guys. Very interesting. Because if you understand this concept, then you will understand this two of K full factorial designs. This is a basic fundamental, right? The theory. The theory. Okay. Okay, this is a graphical into how to calculate the two factor interaction. I think don't worry about this. I think you know how to calculate, but the most important is the mathematics, the one that I just derived. Into this is shown in the graphicals. Okay, this is the example of main effects of A. You know, the estimate using I think here using all this, right? Or you can do this. Remember here, inside here, contrast, contrast of A. Look at column A. Why it's not moving? Okay, let me not. Okay, then cell here is called contrast. Contrast of A, right? Contrast of A. Okay, this contrast of B you get from the matrix. Remember the matrix like this? That the matrix run one, right? To the previous example, right? So you get this, you know, remember you have A, right? You have B, you have C, and then you can get the contrast, similar like the previous example. Okay, contrast. Okay, so if you know the contrast of A, B, AB, so you can derive, you know, C, AB. I think this, you know how to calculate the contrast of the previous example, right? Contrast. This example that I just derived. Remember the previous slide? Yeah. I just derive, you know, using ABC here. Look at this, the contrast. Contrast. Contrast of ABC. ABC. Contrast ABC, right? Contrast ABC. Okay. Okay, this okay. I think the previous example, right? For 2 by 3, okay, for 2 by 3, right? I put here run. You should run, right? Run. 1, 2, 3, 5, 6, 7, 8, right? 2 by 3 equal 8 runs. 2 by 4, 16 runs. 2 by 5, 5 factors. You know, 5 factors A, B, C, D, E. 32 runs. And the rest. Okay. This is main effect of A, main effect of B, right? Main effect of C, right? Main effect of AB, no AB. Usually I put like this, you know, A first, B. Usually I do like this. Usually I like to do this. Remember, A, B, C, right? Many facts, and then I put AB, AB, and then AC, right? And then BC, two-way effect, and then finally A, B, C. Okay, in the textbook they're using like this. It doesn't matter whether you want. This one is much easier because you want to calculate main effects, right? Main effect A, B, C. This one, two effect, you know, A, B, A, C, B, C, and this three-way, you know, this is three-way, right? Three-way. Okay, this is to get the contrast, right? For example, contrast of A, B, C. Right? For example, remember the example, contrast of A, B, C, contrast of A, B, C. Okay, where I want to write, maybe here, contrast, 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 C, contrast, contrast of A, B, C equal to, just follow the sign here, you know, follow the sign. Minus 1, you know, minus 1, right? Minus 1 plus A, minus 1 plus A, look at this, plus B, then minus AB, minus AB, then plus C, no? Plus C, minus AC, minus AC, minus AC, minus BC, minus BC, and then plus ABC, plus ABC. So this contrast of ABC, I think the previous slide they derive it, you know, contrast. So you can derive any contrast of AB, AC. You need to know contrast, so that you can calculate. Remember, sum of square, because you need to construct ANOVA table. Remember that. That's why you know, you must be able to know the contrast, no? Because you want to construct ANOVA table. Okay, this is explanation. I think explanation. Okay, here remember why. You know here. Okay. That's why here, why you need to contrast, create effects, and also here, to calculate sum of square. This is very important to construct ANOVA table. In ANOVA table, remember ANOVA table? ANOVA table, right? You have source of variation, SOV. No, for three factor, you have factor A. Remember, factor A. You have factor B, right? Factor B. You have factor C. This is the main effect. And then you have some two interaction, you know. AB, right? AB, AB, AC, okay. BC, AC, BC, and then you have ABC, two interaction, right? ABC, ABC, and then finally you have error, and finally total. That's why you need to sum of square here. Okay, sum of square. So that's why you need to know SS, no? SS to get all these sum of square of A, B. A that means contrast of A, contrast of B, contrast of C, contrast of and number replicate K is 3. K is 3. K is 3. Okay. Okay, this is a good example, right? This is a good example. Okay, good example for 2 by 3 designs. Good example of 2, sorry guys, 2 by 3 designs. Example. So 2 by 3 should have 8 runs. Run. Run, Run. 8 runs, right? 1, 2, 3, 4, 5, 6, 7, 8 runs. 8 runs. Okay, 8. Okay. This is standard order design, factor A, B, C. Okay. And then replicates 2 times. Okay. I mean 2 by 3%. Okay. This factor A is the depth of cut. And machining, I think this is a machining process. Machining. So any process. I mean, machining process. Machining process. So you have 3 factor. Factor A, B, C, right? And then what is your response severe roughness? Response. So run 2 replicates. Okay, here they mention here. Through the 3 replicates. Okay, to replicate total. Okay. What should you do? Construct ANOVA table. Analyze. Construct construct ANOVA table. Okay, we want to see whether these 3 factors, which is fit rate, depth of cut, or tool angle, right? Effective severe roughness. Effective severe roughness. You want to know which one? Okay, significantly effective roughness. So you need to construct ANOVA table using manual calculation or using Minitab. Okay? This is the data. Okay, this is the data. Two replicates. 2 replicates. Okay. I don't know what is the questions here, but these are the data. This called raw data. Raw data, raw data or data collection matrix, problems, the issues, right? But there is no questions here. 1 minute. I think this is more on application, right? Calculation of many types of A. I think this one. More on, I think, many types of A. I think this one. 1 minute, Many pair of A, correct? Of A. Maybe more on the demonstration, many pair of A. Many pair of A. Calculate sum of square of A. Sum of square A. Okay. By the way, guys, many pair of A, you can do like this also, using the mean. Okay. This is using the formula. You can do also like this, using the mean. Using the mean. Using the mean, using the mean, you can do like this. Mean analysis, excuse me, A negative, sorry guys, main of A plus, is a mean response here, right? Mean, and then she's a plus here, right? She's a plus. So I expecting like this, the graph, mean. So calculate this. This is using the formula. This is using the formula, right? This is using formula. Using formula. Using formula. It's not using the mean. That mean in order to plot this like this. A at low level, you calculate the mean, and then A at plus level, calculate the mean. Calculate the mean. The mean. Okay, the mean. Please take note. Let me check the time. Okay, mean. Calculate the mean. Mean. Okay. Look. Okay, mean. Mean A minus A plus. Mean of A minus. Okay, mean. Please, guys, please record this. I want to. Okay, mean. That mean. Mean A negative. What is the value? Mean A plus. What is the value? Mean. Okay. Look at this. I want to plot the mean. Yeah. Okay. Mean, right? Please take note this. Please take note this because I want to. Please take note this. You need to record somewhere in your notes. Mean. Mean. Refer to the example. Okay, here. Mean. You need to add one more column here. Boleh. Mean, yeah, mean. Mean. Or X bar. For example, here, 16 by 2, 8, right? 8. Mean 8. 32, 11. Mean, 11. This one will be 10. 10.5. 13.5. Calculate, guys, the mean, Calculate the mean for each. 13.5. 10.5. Very difficult to. 10.5. 21. 11.5. Calculate the mean for each rows. 11. I want to show you another method. 9 and 15. Okay, this is a mean, right? Mean for. Okay, if you want, remember A negative. A negative. Look at column A here. A negative, that means 8, right? 8. plus 8 plus negative 10 plus 8, 10, look at this, 10.5, is it? 10.5, 10.5, and then plus 9. So calculate the mean. Okay, and then A plus is equal to, you look at A, column A plus will be 11 plus A plus 13.5 using the mean 13.5 plus 13.5 11.5 plus, and then finally 15. Okay guys, calculate the mean. Okay, 8, right? 8 plus 10, 10.5 plus 9, is it 9? Is it 9? 9 divided by 4. 9.375 here. This one. 9.375. 9.37. Okay. For this one, for A plus 9.375. 9.375 for A plus 11, 13.5, 11.5 plus 15 plus by 2, 20, 20. Okay, so you plot this, you plot like this. You plot A negative, A negative, A, very difficult to, A negative, right? And then this is A plus, A negative 9.375 here. Let's say here, this 9.375, and then 20. Okay, this is 20. I don't know it's correct or not. 20. This is 9.375. 9.375 is it? 9.375. The effects using the mean, the effects should be 20 minus 9.375. Is it correct? 29.375. 10 points, I don't know. 10, is it correct? 10.625. It should be similar using formula. I don't know. Is it correct or not? 10.625. 10.625. Okay, check the number. Is it correct? Rolling, Main effect 3 point. I think something wrong in the. It's not the same. Mean of A 3.3. So I think check again my calculation. Check again. 9 plus 3.375. Oh, okay. Guys, I think you check back again, guys. Check back. I think something not right. My calculation. Very difficult to check again to the numbers. Calculate the x bar here. X bar, right? This is 8. What time now? Okay, we have 10. It's okay. Let me check again. This is 8, right? 8. 8. 11. 10. 13.5, right? 13.5. 10.5. This is 11. 11.5. 11.5, 9. 15, right? 15. 15, okay. A negative. A negative equal to, look at this A negative, 8 plus A negative, A 10 plus 10 and then 10.5, is it? 10.5 plus 9, is it 9, 9. Okay, this A negative. Okay, A plus look at A plus 11 plus 13.5. 13.5 plus 11.5, is it? Okay. 11.5 11.5 plus 15. Okay, calculate again. Why is the difference? 8, 10, 10.5, 9. But by 4, 9.3. Okay, this one 9.375, correct. This one 9.375. Okay, the A plus 11, 13.5, 11.5, 15, right? 4, 12.75, 12.75, 12.75. Okay, like this. A, like this. This is 12.75. This one is 9.375. The effects equal to, okay, 12.75 minus, this is 12.75, right? 12.75 minus 9.375 plus 3.75. 3.375. Okay, this is, I think this one should be correct. So you can do main effects using a formula or using the plot. This is a plot. This is called the plot of main effects of A. So you can do main effects of A. So you can do main effects of B, main effect of C, and then you calculate a plot of interaction effects. Okay. So okay, I think I will continue lah, guys. For I think you can do. Okay, hold minute. This okay. Take this. Take the run one. Right, and then the X bar. I think that's one correct. 8, 11, 10, right? 13, 8, 10, 10.5, 5, 11.5, 9, and 15. Okay. If you know this, right, you can calculate. Okay. First, I think you can plot. We can try at your home. Plot two-way. Plot two-way interaction effect. Plot two-way interaction effect. Interaction effects. Maybe AB, AB. Plot. A, B. Okay, this is I think, guys, for test 1, I think I will not cover 2 by 3 test 1 only cover a single factor in the counting, but for 2 by 3 like this is called 2 by 3. 2 by 3 design I think cover in test 2. I think from this topic onwards is cover for 2 by 3 design is 2 by 3. This I think cover test 2 from this test 2. Test 2. That means test 1 only cover single factor, 2 factor up to 2 by 2, but not 2 by 3. 2 by 3. Okay. Okay, I think this is a good stopping here, right? Good stopping. Okay, nice. I think it's 8:10 now. Okay, guys, I think I will continue, guys, on this topic, right? On this topic. It's stuck now for whatever reason, right? I think. Okay, guys. Thank you very much for listening for this session. Right now, it's almost 10. We should stop here. Right, stop here. We continue discussing on 2 by 3 on the next class. On the next class. Okay. Before we leave, make sure you write your attendance at the chat for my record purposes. Okay. Thank you. Oke, terima kasih.
Thank you, Dokter.
Thank you.
Dokter.